So this is the presentation 4 in straight line graphs lesson. And in this particular presentation, we'll be talking whether a particular point lies on a straight line. So we know that always a straight line is y equals to mx plus c. The question is, does the point 3, 1 lies on the graph y equals 2x minus 4. The x coordinate we usually call it as the input and the y coordinate we call it as the output. So what we have to see here, whether this particular point, which is 3, 1, lies on the graph 2x minus 4. So we input 3 and we check and see whether our output is 1. Y equals to 2 times 3 is 6 minus 4 it is 2. So we can clearly see that when you input 3, your output is 2. It's not 1. So when you input 3, if you are not getting 1, then this particular point is not on this particular straight line. So what we conclude here, the point doesn't lie on the straight line. The point doesn't lie on the straight line. I'll show this to you graphically. I will have a coordinate table. I will input some x values, minus 1, 0, 1, 2, 3 and 4. You know how to prepare the tables from the previous presentations, you learned it. And I will get the relevant y coordinates. So when I get the relevant y coordinates using algebra, here I have shown you the workings as well. I input minus 1, 0, plus 1, 2, 3 and here I plot the graph. You can see this particular point 3, 1. Let me show you. That's 3, 1 is over here where I have my red highlighter. So 3, 1 is not on the given straight line y equals to 2x minus 4. So you can clearly see that 3, 1 doesn't lie on the graph y equals to 2x minus 4. Let's look for another example. Does the point 1, 6 lies on the graph y equals to 2x plus 4? Does the point 1, 6 lie on the graph y equals to 2x plus 4? Let me use algebra. My input is 1. The x coordinate is 1. So y equals to 2 times 1 plus 4. 2 times 1 plus 4 it is 6. So y is equal to 6. Yes, you can see that when you input 1, your output is 6. That means the point 1, 6 lies on the graph y equals to 2x plus 4. I'm not going to show this graphically. If you want, you can assign some x coordinates, get the y coordinate and draw and see this 1, 6 would be a point on the straight line. So our conclusion is yes, the point lies on the graph. Next example, does the point minus 3, minus 7 lies on the graph y equals to x minus 4? Our input here is the x coordinate which is minus 3. Our output should be minus 7. So we're going to check and see y equals to minus 3 minus 4 which is equal to minus 7. So the point y equals to minus 7 is the output. So minus 3, minus 7 is the point which lies on the straight line y equals to x minus 4. So we can conclude as yes, the point lies on the graph. So here is a small exercise for you to try and do. Pause the presentation for a while and see whether you could answer these questions. Further, I have done few questions for you. After you do your exercise, check and see whether your answers are right. So the first one is, does the point 3, 2 lie on the graph y equals to 2x minus 4? You can see that y equals to 2 times 3, the x value is the input. 2 times 3 is 6 minus 4, it is 2. So output is 2. Yes, the point 3, 2 lie on the graph. Next one, does the point 0, 4 lie on the graph y equals to 2x plus 8? Work it out of your own. X coordinate is 0. So y equals to 2 times 0, that is 0 plus 8. So the answer is 8. But the point is 0, 4. So output should be 4, whereas you got the output 8. And it is clear that the point 0, 4 does not lie on the graph y equals to 2x plus 8. Third one, does the point 1, minus 3 lie on the graph y equals 5x minus 4? What you have to do here, you're going to input 1 for x coordinate and you're going to check whether your output is minus 3. If it is minus 3, the point lies on the graph. If it is not minus 3, the point does not lie on the graph. Let's work it out and see. 5 times 1, it's 5, minus 4, it is 1. So your output is 1. When you input 1, your output also should be 1. But according to the point, it is minus 3. So it does not lie on the graph. Other two questions I have not done. So you try and say, you input 0 to the given equation and see whether your output is plus 4. Be careful with the sign as well. And you input minus 8 to the given equation and see whether your output is minus 4. If the output matches the input, then the point lies on the graph. If it is not, the point does not lie on the graph. So this is another new exercise. We are going to find the missing coordinate. So we are going to find the value of a which lies on the graph y equals x plus 3. The question says that the point a, 5 lies on the graph y equals x plus 3. The question says the given point is already lying on the graph. So we are going to find when the y coordinate is 5, when the output is 5, what's the relevant x coordinate, which is the input coordinate. Let me show you how to do this question. So as we know, x coordinate is the input. You're going to input a instead of a value here. And the y coordinate is the output, which is 5. So simply to the given graph y equals x plus 3, you are going to input a, output 5, so that you can find the value a, so that you can find the x coordinate a. Use a bit of algebra and you know that a is equal to 2. So 2, 5 lies on the graph y equals to x plus 3. Next example, the point a, minus 1 lies on the graph y equals 2x plus 3. So the input here is a and the output is minus 1. So let's work out minus 1 equals 2 times a plus 3. Use algebra. then it's minus 4 equals to 2a. You're going to remove 2 from a, so we divide both sides by 2, and a is equal to minus 2. So you can clearly see in this question they are not asking whether the relevant point is on the graph. Question says that the given point is already there in the graph. Find the missing x or y coordinate is what you have to do. In the former examples, they asked a question from us whether a particular point lies on the graph. So your answer is a yes or a no. In this case, it's not asking a question from us for a yes or a no answer. You have to find the x or y coordinate because already the given point is on the straight line. So please understand the difference between the previous question and this. Look at the next one. The point b, 6 lies on the graph y equals 3x minus 3. So you can substitute the values and see the b is equal to 3. The b is equal to 3. Let's continue. The point 6, b lies on the graph y equals to x minus 4. The question says 6, b lies on the graph y equals to x minus 4. So your input is 6, which is the x coordinate. Your output is b, which you are going to find. Let's work it out. So b equals 6 minus 4. That's b equals to 2. Next example. The point 4, t lies on the graph y equals 8x plus 3. So you can see the input, which is the x coordinate, is 4, and the output, the y coordinate, is t. So you're going to work out for the value of t. T equals to 8 times 4 plus 3. So 8 times 4, it is 32, plus 3, it's 35. So the t, the y, relevant y coordinate is 35 when the x coordinate is 4. Next one. The point a, 5 lies on the graph y equals 1/3 x minus 5. So this one is for you. You try and work it out. You have to input a. So your output need to be 5. Here I have worked the answer. 5 equals 1/3 a minus 5. Minus 5 returns to the other side. So it's 10 equals to 1/3 a. I multiply both sides by 3. A is equal to 30. So the x coordinate is 30 while the y coordinate is 5. These are some worked examples. So you try and see the questions of your own and check with the answers whether you are getting the same answer. You can correct yourself by looking into these examples. I'm going to continue the presentation 5 with the midpoint of a straight line. So please look into presentation 5 to continue this lesson.